Chapter number 13. Magnetism. Friends, we know that certain substances possess the property of attracting small pieces of iron. This property is called magnetism. The word magnetism has its origin in the name of an iron ore called magnetite. Magnetite, the natural magnet called as lodestone, showed magnetic properties. We know that magnet has attracting and directive property. A freely suspended magnet always points in the north-south direction in horizontal plane. Its north-seeking pole is called N-pole or north pole, which is positive pole, and south-seeking pole is called S-pole or south pole, which is negative pole. Like poles repel and unlike poles attract each other. Earth has its own magnetic field. Earth behaves like a huge magnet with its magnetic north pole near geographical south and magnetic south pole near geographical north. The Earth's magnetic field points approximately from geographic south to the north. Because of this, a freely suspended magnet points in the north-south direction. When a magnet is cut into a number of pieces, each piece is found to be a small magnet of weak magnetism with south and north poles. Therefore, south and north poles do not have independent existence. There is no isolated magnetic pole or monopole. Magnetic poles are said to be fictitious or imaginary. A magnet is also called a magnetic dipole. The region surrounding a magnet in which its effect can be experienced is called magnetic field. A magnetic field is represented by magnetic lines of force. Magnetic lines of force start from north pole and end on south pole, and within the magnet they move from south pole to the north pole. The properties of magnetic lines of force are similar to that of the properties of electric lines of force. We know that the strength of electric field is expressed in terms of vector quantity called the electric intensity vector E. In a similar manner, the strength of magnetic field is expressed in terms of a vector quantity called the magnetic induction vector B. Magnetic flux is defined as the number of magnetic lines of force passing normally through the given area. SI unit of magnetic flux is Weber and is denoted by WB. Magnetic induction at a point in a magnetic field is equal to the magnetic flux per unit area at that point. Therefore, magnetic induction B is equal to magnetic flux upon area that equals to phi upon A. In SI unit, it is expressed as Weber per meter square or T star. Now let us understand some terms. Axis. It is the line passing through both the poles of a magnet. Equator. It is the plane passing through the center of the magnet and perpendicular to its axis. Magnetic length 2L. It is the distance between the two poles of the magnet. Magnetic length 2L is equal to 5 upon 6 into geometric length. Pole strength M. It is defined as the concentration of strength of magnetism at the poles. For North Pole, it is plus M, and for South Pole, it is minus M. Its SI unit is ampere meter.